Welcome back, students. In this session, we will be dealing with the topic power. And power is defined as the rate of doing work or rate of transfer of energy is known as power. So, power is rate of doing work or rate of transfer of energy. Rate of doing work or rate of transfer of energy. That is meant by power. That is, power actually tells us how fast or how slow a work is being done. For example, take a person who is on a bicycle and another person who is on a bike, and you are asking both the persons to reach a particular destination. What will you observe? Yes, you can see that the person who was there on bike will reach the destination faster than the person who was there on the bicycle. It is because the power of the bike is greater than the power of the bicycle. That is, the rate at which work is done is more in case of bike compared to bicycle. Now consider another example. You are asking a kid to run. At the same time, you are asking a boy who is around say 15 years old to run along with this kid. Who will reach faster? Definitely the boy around 15-year-old, because he is stronger or more energetic compared to the small kid. So the power of that boy is greater than the power of the kid, or the rate at which the boy does work is more compared to that of kid. So the power gives us or tells us how fast or how slow a work is being done. It gives an idea how fast or slow a work is being done. Okay, this is the power. Now, according to definition, power is rate of doing work. This rate of, the word rate of means divided by time. Rate of means divided by time. Rate of doing work. So, a work is done. So, power is W by T. We know that all the work done is stored in the form of energy. So, work done and energy are equivalent terms. So, instead of W, we can write E by T. This is the formula for power in terms of work and in terms of energy. P is equal to W by T. P is also equal to E by T. And SI unit of power is watt, and represented using the letter, capital letter W. Watt is the SI unit of power. Now, we know that P is equal to W by T and SI unit of power is watt. Now, can you define 1 watt using this formula? So, instead of power, power is 1 watt. In order to get the power as 1 watt, work should be 1 joule by time should be 1 second. 1 joule by 1 second will give you 1 watt. Power is equal to work by time. So, unit power is unit work by unit time. Now, how can you define this 1 watt? 1 watt is the unit of power. So, 1 watt is the power, 1 watt is the power when work is done, when work is done at a rate of 1 joule per second. 1 watt is the power. 1 watt is the power when work is done. When work is done, when work is done at a rate of 1 joule per second. 1 joule per second. When 1 joule work is done using 1 second, the power is known as 1 watt. When 1 joule work is done using 1 second, then the power is known as 1 watt. So 1 watt is the power when work is done at a rate of 1 joule per second. Now coming back to energy, we know that the unit of energy is joules. The unit of energy is joules. SI unit of energy is joules. But have you seen the electrical meter reading? The electrical meter reading bill? The bill of your electricity bill of your house? Over there, the electrical energy are expressed in units. Okay, over there the electrical energy are expressed in units because joule is the smaller unit of energy. Joule is the smallest unit of energy. In order to express bigger units, because electrical energy of our house is too big, the consumption of electrical energy is too large. So to express such large quantities, we have larger units of energy called commercial unit of energy, and the commercial unit of energy is kilowatt hour. Commercial unit of energy is kilowatt hour and the SI unit of energy is joules. So SI unit of energy is joules. It is a smaller unit. For larger purposes, we make use of commercial unit of energy called kilowatt hour. Now let us see how this commercial unit of energy and the SI unit is related. Okay, we know 1 kilowatt hour, that is a commercial unit of energy, can be written as 1 kilowatt into 1 hour. This is 1 kilowatt hour. 1 kilowatt hour is 1 kilowatt into 1 hour. Okay. Now 1 kilowatt is 1000 watt. 1 kilowatt is 1000 watt, and now converting hour into seconds. Now to convert hour into seconds, we should multiply with 60 into 60. To convert hour into seconds, we just multiplied 60 into 60. To convert kilowatt into watt, we just multiplied with 1000. So 1 kilowatt is 1000 watt and 1 hour is 60 into 60 seconds. Now 1000 watt, in terms of exponents it is 10 raised to 3 watt. Since it has 3 zeros, in terms of exponents it is written as 10 raised to 1000 is written as 10 raised to 3 into 60 into 60 is 3600 seconds. That is 10 raised to 3 into 36 into how many zeros? 2 zeros. It can be written as 10 raised to 2. So 36 into 10 raised to 2 is 3600. We just converted it into the exponent form. That is 1 kilowatt hour is 36 into 10 raised to 3 into 10 raised to 2. A raised to m into a raised to n is a raised to m plus n. So that is 10 raised to, instead of m we have 3 and instead of n we have 2. M plus n, that is 3 plus 2, that is 5. So much joules. We have converted kilowatt hour into joules. We have converted commercial unit of energy into the SI unit. That is 1 kilowatt hour is 36 into 10 raised to 5 joules. This is how we convert the commercial unit of energy into the SI unit of energy. Hope the conversion is clear. Now, let us do a numerical question. Page number 156, you have a set of blue questions over there. In that question, question number 3. In that set, question number 3. Page 156. Question number 3. A lamp consumes 1000 joule of electrical energy in 10 seconds. What is its power? So, a lamp consumes 1000 joule of energy. So, energy is given as 1000 joules and it is consuming in 10 seconds. So, time is 10 seconds. What is its power? We need to find power. The formula to find power is W by T is also equal to E by T, and we know that power is equal to, it is given E is 1000 joules. So, power is 1000 joules by time is given as 10 seconds. So, instead of E substitute 1000 joules, instead of T substitute 10 seconds which is given in the question. So, we get power as 0 and 0 gets cancels off. So, power is 100. SI unit of power is watt. So, power is 100 watts. Okay. Hope the formula is clear now. So, we have just discussed about the topic power. Power tells us how fast or slow a work is being done. That is, a rate of doing work or rate of transfer of energy is known as power. And the SI unit of power is watt. Larger unit of power is kilowatt. And formula to find power is W by T or E by T. P is equal to W by T or P is equal to E by T. Now, commercial unit of energy is kilowatt hour. To convert commercial unit of energy into joules, we have the conversion 1 kilowatt hour is equal to 36 into 10 raised to 5 joules. This is what we have covered in this session. Hope it is clear. Thank you.